Okay, welcome to another video being brought by the 100% Tyler group. So here we'll be looking at all the quant section slot 2 problems, and we'll be looking all the solutions in detail so that every student is able to get the solutions. This is something about me, so yeah, you can go through it later. So let's get started with the questions. Okay, the first question here is in a car race, car A beats car B by 45 kilometers. So when we say that car A beats car B by 45 kilometers, it means that when A has completed the race, so let's say the total race distance is X, then B has reached here, which is 45 kilometer from the finish line. So therefore, let's say the speed of A and B are VA and VB. Then we know here that X upon VA is equal to X minus 45 upon VB. So we have simply used time equal to distance upon speed. Okay, next we are given that car B beats car C by 50 kilometers. So once again, X upon this time B is completing the race and C is yet to complete it by 50 kilometers. And finally, A beats C by 90 kilometers. So X upon VA is X minus 90 upon VC. Now there are three equations and three variables, and we have to find the distance over which the race has been conducted, that is value of X. So we have to simply eliminate three of them. So let's try to get the ratios VB upon VA from here and from these two equations and then equate them. So from the first equation, VB upon VA is X minus 45 upon X. And from the other two equations, if we divide the second equation from the third one, we get VB upon VA equal to X minus 90 upon X minus 50. Now we cross multiply. X square minus 50x minus 45x is minus 95x plus 50 into 45 is 2250, which is x square minus 90x. So therefore 5x is 2250 and therefore x is 450. So therefore 450 is the required distance of the race here. Going to the next question, we are given here from the interior point of an equilateral triangle, perpendiculars are drawn. So let's draw a triangle. Now we are given that perpendiculars are drawn on all the three sides from any point in the triangle. The sum of the lengths of the perpendiculars is x. So the sum of these three lengths is given to be s. The area of the triangle is, okay, so there could be like very complex solutions to solve this, but what we'll do here is we are given the freedom to choose this point as any point inside the triangle. And we know that for an equilateral triangle, the median and altitude are the same. So let's consider this point actually to be the intersection point of the three medians of the triangle. Now we know that these points divide the median in the ratio of 2:1. Also, since this is the median, this will be, let's say the side is A, then this will be A by 2 and this will be A. Therefore, the median length is root 3 A by 2. We simply use the Pythagoras to get this length. Therefore, the length of this side would be what? A upon 2 root 3, which is 1 upon 3 times this length. Therefore, we get this particular length. Now, S is the sum of three of these lengths. So, S will be nothing but root 3 A upon 2. Now, this once we get S, we know A is 2S upon root 3. Area of the triangle is root 3 upon 4 A square. Therefore, putting the value of A in terms of S, we get this particular equation, which is nothing but s square upon root 3. Therefore, s square upon root 3, that is C, is the required answer. Okay, in a group of 10 students, the mean of the lowest 9 scores is 42. So we are given the mean of the lowest 9 scores is 42, which means sum of 1 to 9 scores is 42 multiplied by 9, which is 378. Now the mean of the highest 9 scores is 47. Therefore, for the last 9 scores, the sum would be 9 times 47, which is 378 plus 45, which is 423. Now for the entire group of 10 students, we have to find the maximum possible difference between the minimum and the maximum mean possible. So basically with this information, we have to first find the maximum mean and then minimum mean, and then we have to find the difference between these two. Now for maximum mean, we maximize the 10th value because it is anyways the maximum value, because we are arranging the values in, let's say, ascending order here, and we want to maximize the 10th value because first value will be the minimum one. We would want to have a greater value, and that is why we'll maximize the 10th value. Now we already know the sum of the first 9 values is 378. Now the 10th value will be maximum when all these 9 values are equal to each other. So we can say that all of them would be equal to 42, since that is the mean. And therefore A10 is computed as S210. We know the sum of the last 9 values is fixed, minus 8 times 42. This is nothing but S229. Therefore 423 minus 336. This is 87. Therefore S total would be 378 plus 87, which is 465. Now for minimum mean, we minimize the first value here, which is again minimized when we keep all the values from 2 to 10 equal to each other, which is 47, which is the mean. Therefore A1 is nothing but 378 minus 47 into 8, which is 378 minus 376, which is 2. Therefore minimum sum is 423 plus 2, which is 425. Therefore difference in means is computed as 465 minus 425 divided by 10, which is 4. Therefore 4 is the required answer here. Okay, coming to the next question. Here we are given that x is greater equal to y greater equal to minus 20, and 2x plus 5y is equal to 99. So here we can first see that 2x is equal to 99 minus 5y, and therefore for x to be an integer, 99 minus 5y has to be even. Therefore y has to be odd. Now let's first look at what is the minimum value of y. For minimum value of y, we know that y is greater equal to minus 20, but y has to be odd. So let's check with y equal to minus 19. X equal to 99 minus 5 into minus 19 divided by 2. This is 97, and this is also greater equal to minus 19. So this condition is also satisfied here. Now we know that y equal to minus 19 is the minimum y, which is possible. So we look at the maximum possible value of y now. Now let's say, let's look at y equal to 10. So 2x, but y has to be odd, so let's look at 11. 2x minus 99 minus 55. So x is nothing but 22 and it is greater than 11. So this is fine. Y equal to 13. So we are just using a hit and trial method here. 99 minus 5 into 13. Here x is equal to 99 minus 65. So x will come out to be 17, which is again greater than 13. And if we see for y equal to 15, we will get x less than y, and therefore this will not be a possible value. So therefore y max is 13 and y min is minus 19. Now from minus 19 to minus 1 there are 10 values, and from 1 to 13 there are 7 values. Therefore 17 is the required number of pairs of integers xy that it satisfies the given equations. Okay, going to the next question. So we have log of a upon b to the base a is equal plus log of b upon a to the base b. We have to find this particular value for 1 greater than a less than b. So this is just to satisfy the log conditions. This can be written as log a to the base a minus log b to the base a plus log b to the base b plus log, that's minus log a to the base b. So this is 1, this is 1. So we are left with 2 minus log ba minus log a to the base b. These are reciprocal of each other. We can write this as 2 minus k plus 1 upon k. Now we know that this particular value has to be always greater or equal to 2. Therefore, if this is L, then minimum value of L is 2 minus 2, which is 0. That will be maximum L actually, because we have minus sign here. So therefore this will be the maximum value of L. So if we take k plus 1 upon k if it is greater or equal to 2, let's say it's 3, then 2 minus 3 is minus 1. So therefore maximum value of L is 0 and no value of L greater than 0 is possible, and therefore B is the possible answer. B is the answer here, because that is the only value which is greater than 0. Now here we are given the mth and nth terms of a geometric progression are 3 upon 4 and 12, where m is less than n. If the common ratio of the progression is r, then the smallest possible value of r plus n minus n. So here we are given the mth and nth values as 3 upon 4 and 12. Therefore this can be written as, so we just use the formula for the general term of a geometric progression. So this can be written as like this. Now we're given that m is less than n. So dividing first equation from the second, we are left with r raised to power n minus n upon 12, 3 upon 4, which is 16. Now we have to find the minimum value of r plus n minus n. Now r raised to power n minus m is 16. Therefore this can be written as 16 raised to power 1 4 square 2 4 minus 2 raised to power 4 minus 4 raised to power 2, and that's it. We cannot write it as minus 16 raised to power 1. That will make it minus 16. Okay, so simply adding the r and the power, we get 17 here, 6 here, 6 here, 2 here, and minus 2 here. Clearly this is the minimum value. Therefore minus 2 is the required answer here. Okay, looking at the next question, we are given here that x plus y is equal to 102, and we have to find the minimum possible value of 260, 1, multiplied by 1 upon 1 plus x multiplied by 1 upon 1 plus y. Now this can be simplified as 1 plus 1 upon y plus 1 upon x plus 1 upon xy. So this can be written as, so x plus y we already know as 102 plus 1 xy is 2601 1 plus 103 upon xy. Now for the minimum value of this, we need the max value of xy, and whenever there is a product term and we are finding the max value, we use am greater equal to gm. Therefore gm, which is xy root, is less than equal to x plus y upon 2. Therefore root xy equal to 51, and therefore xy minimum value is 51 square. Maximum value in fact is 51 square. So we can simply put that here to get this is actually equal to 51 square. Therefore we'll be left with 2601 plus 103 and 2704. This is the required minimum value of the given expression. Now for the same principal amount, let's say P, the compound interest for 2 years at 5% per annum. So compound interest per year at for 2 years would be 1.05 square minus 1 into P. So this is nothing but, so if we basically solve it using x square minus y square equal to x plus y into x minus y, we will be left with 2.05 into 0.05. So this we can 1025p exceeds the simple interest for 3 years at 3% per annum. So simple interest for 3 years at 3% per annum would be 0.09p. Now subtracting these two, we get 1125, which is p as 1125, and therefore p, which is the asked value, is this. This can be simplified. Okay, so looking at the next question, C is a circle of radius 5 meters having center O. Let PQ be a chord of C that passes through points A and B, where A is here 4 meters from O and B is 3 meters east of O. Then the length of PQ in meters. So the chord here could be drawn as this. So this is B and this is A. So we are given this is 4, this is 3, and this is PQ. So for the length of the chord, if we know the perpendicular distance of the chord from the center, we would know the length. So first we will calculate the perpendicular distance of the chord from the center. So let this be equal to h. Now this base is 5 using Pythagoras. Therefore area of the triangle, which is half into 3 into 4, should be equal to half into h into 5. Therefore h is 12.5, which is 2.4. Now if we have a circle, and this is 2.4 and this is 5, which is the radius, then length can be computed as 25 minus 2.4 square, which is, so this is 5.76. So we'll be left with 19.24. And therefore L by 2 is root of 19.24, which is 4 point some value. Looking at the options, if we divide each option by 2, we'll be getting 3.3, 3.6, 4.4 and 3.9. There's only one value, which is 4.4, therefore 8.8 is the required answer here. For real x, the maximum possible value of x upon root of 1 plus x4. Now the best way here would be to solve it using the objective approach. So looking at the maximum value in the options, we see 1 is the maximum value. So equating this to 1, we get x square equal to 1 plus x4. x4 minus x square plus 1 equal to 0. This clearly has a discriminant of less than 0 and therefore no possible value of x exists. Going to the next one, we have 1 upon 2. So here we'll have 4x square equal to 1 plus x4. 1 plus x4 minus 4x square equal to 0. And here the discriminant would be, which is greater than 0. Therefore, there is a possible value of x for which the value of the expression is 1 upon 2 and therefore B is the correct answer here. Now Anil buys 12 toys and label them with the same selling price. So let that selling price be S. He sells 8 toys initially at a 20% discount on the labeled price. So the total revenue here is, for 8 toys, it's 0.8 times S. He sells the remaining 4 at an additional discount of 25%. So additional discount on 25% on this would be 3 upon 4 into 0.8, which is 0.6. Therefore 4 into 0.6 S. This is 8.8 S. Thus he gets a total of 2112. So this is 2112, which is making a 10% profit. So if the cost price was C, then this is 1.1 times 12C. So with no discounts, his percentage of profits would have been, so we'll simply find the values of S and C from here. So S is 2112 upon 8.8, which is so S is 240 and C is 160. Therefore, without any discount, the profit percentage is 240 minus 160 upon 160, which is 50%. Therefore, B is the required answer. Now, x and y are non-negative integers. So we know that x is greater than 0, greater or equal to 0, and y is greater or equal to 0. We given x plus 9 is z and y plus 1 is z. Also, x plus y is less than z plus 5. Therefore, if we put everything in terms of z here, we get 2z minus 10 less than z plus 5. Therefore, z is less than 15. Now, as x and y are integers, z is also an integer. So, z max would be 14 as the integer value. We have to find the maximum value of 2x plus y, which is nothing but 2 into z minus 9 plus z minus 1, which is 3z minus 19. Now we already know maximum value of z is 14, therefore we can put that in and get the required answer. This is the maximum value of the given expression. Now students in a college have to choose at least 2 subjects from chemistry, maths and physics. The number of students choosing all 3 is given to be 18. choosing mathematics as one of their subjects. So mathematics as one of their subjects is 23. So out of this, we already know that M and C plus M and P would be 23 minus 18, which is 5. Similarly, for physics, as one of the subjects is 25. So therefore, because this all three will be coming in all the equations. Now we have to find the smallest possible number of students who chose chemistry as one of their subjects. So we have to basically minimize the sum of these two values. Now clearly what we can do here is these two are common values. Therefore we maximize this to 5. Note that it cannot be greater than 5 because otherwise this will become greater than 5. So therefore putting this as 5, we get this particular value as 2 and this as 0, and therefore the sum is 2 here, and therefore for chemistry we have 18 plus 0 plus 2 equal to 20. Therefore 20 is the required answer. Here we are given fx as x square plus ax plus b and gx as fx plus 1 minus fx minus 1 for all real x. We are given that g20 is equal to 72. Therefore, now first let's find it in terms of x. We will be left with x. So x plus 1 whole square plus a x plus 1 plus b minus x minus 1 whole square plus a x minus 1 plus b. So b gets cancelled out. X square plus 1 will also get cancelled out. We'll be left with 4x and plus a and plus a, so plus 2a. This now g20 is 72, therefore 80 plus 2a is 72, therefore 2a is minus 8 and a is minus 4. Now we are given that fx is greater or equal to 0, therefore x square plus, that's minus 4x plus b is greater or equal to 0. Therefore, b is greater or equal to 4x minus x square. Now, we need to somehow make this a perfect square because we know that perfect squares are greater or equal to 0. Therefore, b is greater or equal to minus of x minus 2 whole square, but it will have an extra minus 4. So, we get plus 4 here. And therefore b is greater or equal to 4. Therefore 4 is the required answer here. Okay, so here we are given the distance from b to c is thrice that from a to b. So let's have the distance from a to b as x, then this is 3x. Two trains travel from a to c via b. The speed of train 2 is double that of v1. So if this is traveling by v, this is 2v. While traveling from a to b, and their speeds are interchanged while traveling from b to c. So here this becomes 2v and this is v. The ratio of the time taken for a and versus time taken from 2. So this is an easy one. So we simply do time is equal to distance upon speed. And this is 2.5x upon v. This is x upon 2v plus 3x upon v, which is 3.5x upon v. Therefore, 2.5 upon 3.5, which is 5:7 is the required ratio. The sum of the perimeters of an equilateral triangle and a rectangle is 90. So therefore, we can have 3a plus l plus b twice is 90. The area of the triangle T and the area of the rectangle R satisfy the relationship R equal to T square. If the sides of the rectangle are in the ratio 1:3, so that's this be 3x, this be x, then the length in centimeter of the longer side of the rectangle is, so we have to find 3x here. Now this can be written as 3a plus 8x equal to 90. Now on this we can write 3x square as the area of rectangle is equal to area of the triangle square. So the 3 gets cancelled out here and we'll be left with a square equal to a raised to power 4 equal to 16x square, and therefore a square equal to 4x. So this equation, putting x equal to a square upon 4, we get 3a square plus 2a equal to 90. 2a square plus 3a minus 90 equal to 0. This can be written as, so we are just factorizing here. So a is 6, therefore x is 36 upon 4, which is 9, and therefore 3x is 27. Therefore 27 is the required length of the side here. Now the number of integers that satisfy the equality x square minus 5x plus 7 raised to power x plus 1 equal to 1. Now this can be equal to 1 in the following ways. If a raised to power 0 is 1, 1 raised to power anything is 1, and minus 1 raised to power even number is 1. So first, looking at the case, a raised to power 0 equal to 1, x plus 1 is 0, so x is minus 1. Checking the base as well, so minus 1 square plus 5 plus 7, this is greater than 0, so this is fine. So one of the answer is x equal to minus 1, that satisfies it. Now 1 raised to power x is 1, 1 raised to power a is 1, so we have x square minus 5x plus 7 as 1, which is x square minus 3x. So this actually becomes plus 6 equal to 0, and therefore x square minus 3x minus 2x plus 6, 0. This is x minus 3, x minus 2 equal to 0, and therefore x is 2 or 3. So there are two more integer solutions here. Now looking at the third case, will be x square minus 5x plus 7 equal to minus 1. So this becomes plus 8 equal to 0. This is, so there is no possible integer here, and therefore x cannot be an integer here, and therefore 3 is the required answer. Now in how many ways can a pair of integers xa can be chosen such that x square minus 2 mod x plus mod of a minus 2 is equal to 0. So this can be written as mod of x square minus 2 of mod x plus mod of a minus 2 equal to 0. So here mod x is nothing but 2 plus minus root b square minus 4a mod of a minus 2 on 2. Now for a greater than 2, we have 2 plus minus root 4 minus 4a plus 8 on 2. 2 plus minus 12 minus 4a upon 2. And now we need this to be a perfect square for this to have an integer solution. So we can further simplify first. This has 3 minus a. Now as a is greater than 2, a has to be 3. So otherwise this will become negative. Now for a equal to 3, we have x equal to 1. Mod x equal to 1, and therefore x can be plus 1 or minus 1 here. Now similarly for a So this is actually greater or equal to 2. A can also be equal to 2 here. So in that case, x will be 1 plus minus 1, which is x can be 2 or 0. Now for 2, we can have minus 2 and plus 2 for x, and 0 will be 0. So 3 more solutions here. Now for a less than 2, we have mod x equal to 2 plus minus root 4 minus 4 2 minus a on 2. This is 1 plus minus root 1 minus 2 minus a. This is 1 plus minus root a minus 1. Now as a is less than 2, we can have a equal to 1 here. This will become 1 plus minus 0, which is 1. Therefore x can be minus 1 plus 1 and a 0. So this is one more, these are 2 more solutions here. So total we have 7 solutions here, and anyways, as there is no option greater than 7, we don't have to check further. Therefore 7 is the required number of pair of integer solutions here. Now here we are given 2 tracks T1 and T2 of 100 meter and 20 meter touch each other at point A. So there are 2 tracks which touch each other at point A. Let's say this is 100 and this is 20. Now starting from point A, at the same time, Ram and Rahim are walking on track T1 and track T2 at speeds 15 and 5. So let's say this is 15 and this is 5. The number of full rounds that Ram will take before he meets Rahim again for the first time. Okay, so they can meet only at point A. So this is the single meeting point here. So as it is easy to understand from here, we first need to find time for complete round for both of them. So here we'll have 2 pi r upon speed, which is 15, and therefore simplifying this we get 40 pi upon 3. And for Rahim we will have 2 pi r upon 5, which is 8 pi. Now clearly 8 pi is less than 40 pi upon 3. Therefore 40 pi upon 3 upon 8 pi would be 5 pi upon 3. So we need to multiply this. It's actually 5 upon 3. So the ratio of their completing times is 5:3. So we need to find the LCM of these completing times to find a common meeting point. So that is clearly 15. So this will complete 15 rounds. So 15 will be actually the time here, and if 15 is the time, total rounds completed by the first one would be 15 upon 5, which is 3, and total rounds completed by the second one would be 15 upon 3, which is 5. But we have to find it for Ram, therefore 3 is the required answer here. So for Rahim it would be 5 rounds, and for Ram it will be 3 rounds. Okay, A and B are 2 points on a straight line. Ram runs from A to B while Rahim runs from B to A. So we have here 2 points A and B. Ram goes from A to B and Rahim goes from B to A. After crossing each other, Ram and Rahim reach their destinations in 1 minute and 4 minutes respectively. So let's say this is the meeting point. Let's call this distance x and this as y. Now Ram takes 1 minute, so the remaining distance is y for Ram, and he takes 1 minute to reach that distance, while Rahim takes 4 minutes. Therefore, dividing these two, we have here y upon x equal to 1 upon 4 v Ram upon V Rahim. Okay, next we are given, we know that they met first time at this particular point. Therefore, from this we also know that y upon V Rahim is equal to x upon V Ram. Therefore, y upon x is also equal to V Rahim upon V Ram. We have to find the ratio of Ram speeds to Rahim speed. So, V Ram upon V Rahim is 4. Therefore, 2 is the required ratio here. Now, here we are given C1 and C2 are concentric circles where C1 has a diameter 2 cm longer than that of C2. Now, if diameter is 2 cm longer, then radius would be 1 cm longer. So, this is 1. Now, if the chord of C1 has a length of 6 and is tangent to C2, so the chord is something like this. Let's call this small r. This we already know as r plus 1. So this is perpendicular and this will be half of the total length because a line perpendicular from the center to the chord bisects the chord. So therefore this is 3. So we can simply apply the Pythagoras theorem to get the value of r. The value of r comes out to be 4. Diameter of C1. Now diameter of C1 is 2r plus 2, which is 10. Therefore 10 is the required value. Now John takes twice as much time as Jack to finish a job. So if John does x work per unit time, then Jack would do 2x because John takes twice as much time. Now Jack and Jim together takes 1/3 of the time to finish the job than John takes working alone. So Jack and Jim together takes 1/3 time of John alone. So this will get multiplied by 3x because the time taken is 1/3, so total work done would be 3x. So therefore Jim alone is nothing but 3x minus 2x, which is x. Now moreover, in order to finish the job, John takes 3 days more than that taken by 3 of them working together. So all of them working together will do 4x and they'll take suppose n days to complete the work, while John does x work and he takes n plus 3 days. So therefore 3xn is equal to 3x and n is equal to 1 here. Therefore total work is nothing but 4x. Now in how many days will Jim finish the work working alone? Jim does x work per day and therefore 4x upon x, he'll take 4 days to finish the work. So 4 is the required answer here. In May, John bought the same amount of rice and same amount of wheat as he had bought in April. So let's have April, May, rice, wheat. So suppose rice bought is x quantity and wheat is y quantity, but spend 150 more due to price increase of rice by 20%. So this is 20% increase and 12% increase for the wheat. So therefore 0.2x plus 0.12y is the extra money which is being spent here. Now if John had spent 450 on rice in April, so April it was spent x, let's say price of rice x PR. So we also have to multiply the price here. So let's keep it price PR and price PW. So x PR we are given to be 450 here. That is the total amount spent in April on rice. So putting this value here, 0.2 into 450 is 90 plus 0.12 YPW is 150. Therefore 0.1 YPW is 60 and therefore YPW is 500. We have to find how much did he spend on wheat in May. So we have to find the increased price here, which is 1.2 times 500. That is actually 1.12 times 500. So this particular price, this will come out to be 560. Therefore 560 is the required amount here. Now Aaron bought some pencils and sharpeners. So let the pencils be X and sharpeners be Y. Spending the same amount of money as Aaron, Aditya bought twice as much pencils and 10 less sharpeners. So let the price be PP plus Y PS is equal to 2X PP plus PS into 10 less sharpeners. So this gets cancelled out. We are left with X PP is equal to 10 PS. Now if the cost of one sharpener is 2 more than the cost of pencil, so this is XPP, this is PP plus 2. So therefore X is 10, 1 plus 2 upon PP. Find the minimum possible number of pencils bought by Aaron and Aditya together. So together they bought 3X pencils. Now the minimum value of X is when this particular becomes 1. This cannot be 0, this has to be 1 because X is an integer. Therefore X minimum is 11 and therefore 3X minimum is 33. Therefore 33 is the required minimum number of pencils bought by them together. Now a sum of money is split among Amal, Sunil and Meeta. The ratio of shares of Amal and Sunil is 3:2. So this is 3x and this is 2x. And that between Sunil and Meeta is 4:5. So this is 2x upon 4 into 5, which is 2.5x. The difference between the largest and smallest of these shares is 400. So largest is 3x, smallest is 2x. This is 400. So x is 400. We have to find Sunil's share, which is 2x, which is 800. So 800 is the required answer. How many 4-digit numbers, each greater than 1000 and each having all 4-digit distinct, are there with 7 coming before 3? So here we take this we'll do by counting principle. So let's count the various cases here. Let's keep 7 one extreme end. So 3 could either come here or here or here. So there are 3 places to fit 3, and rest of the 2 digits, so all 4 digits have to be distinct. Therefore rest of the 2 digits can be filled in 8 into 7 ways, because we are left with 8 digits after we have filled 7 and 3. So this will come out to be 168. Now next case is 7 at the next place. Now 3 could come here or here. Now in each case this particular digit could be filled only in 7 ways, because this cannot be a 0. But the remaining place would still have 7 ways to be filled, because once we have filled 3 digits, we'll be left with 7 digits. So this is 2 cross 7 cross 7. Therefore 98 cases. Next we have 7, 3. So there's only one case here, and we can fill the digits in 7 cross 7 ways, which is 49. So adding these 3 values, we have 168 plus 147, which will come out to be 315. Therefore 315 is the required number of numbers here. So if you feel any doubt, just post it on the Facebook group and we'll be